Okay. So, plan for today is we're going to go through the first 7 problems that are going to be on day 1 of your test. So these problems are the calculation problems. You are going to be allowed to use your graphing calculator for this first day because there is a graphing calculator problem. So you need that for the first one. And you guys know the rest of them, it doesn't really help you, but you can at least use the graphing calculator to check your answers. So you'll have that. So day 1 of the test on Tuesday is what we're covering today, calculations. Day 2 on Wednesday next week is going to be the proof portion, where you're going to have a certain number of proofs and you're going to have to prove so many out of them, like I think there's 6 maybe, and you're going to have to prove 4, and then the other ones are what the bonus is. So kind of like what we did with that quiz before too, okay? And we'll practice those on Monday together, more proofs. All right, so first problem on the test is you are disproving one of these, and you're going to do it 2 different ways. You're going to do it graphically, and you're going to do it algebraically. So pick a problem to start here. 50. Okay, so we are going to disprove sine 2x over 2 equals sine x. Okay. So disproving that graphically, use your graphing calculators. So what we're going to do is in y equals, we're going to put half of the equation in y1 and the other half in y2. We're going to compare the 2 sides. So sine 2x. Remember, if you want to square a trig function, you end the parentheses and then you type the squared in. Okay. Here we don't have that. And then I'll just put over 2. You could also, for this one, use your alpha y equals button if you want. And then for the other side, sine x, and my parentheses. Okay. All right. So now we want to graph it. The best way to look at these graphs is in radian mode. So double check your mode, that you are in radian mode. If you're not, fix it. And then just your standard window should work. So zoom 6. And there's the first graph, and there's the second graph. And we're trying to show that they're not the same. You can see they're not the same. So on the test, you would just make a sketch of that and show that you have 2 different pictures. Okay, so that disproves the identity. Okay, the other way to do it is algebraically. And algebraically is not with identities. We only use identities when we're trying to prove something and we know that this is not true. So for this, you're going to use a counter example. You're going to find an angle, and you can pick any angle you want, that gives you 2 different things when you plug it in, one on the left and one on the right. And you can pick something off of your unit circle to make it easy because then you don't need your calculator at all for it. Remember, you'll have a blank unit circle. Ones that are good to use are sometimes like 30 and 60 degrees. They're in quadrant 1, so nothing crazy as far as like positives and negatives, but we sometimes get some like false positives when we choose 0 and 90 degrees, things like that. Even though we get nice pretty numbers, 0 can make things disappear and not give us the counter example we're looking for. So that's where I would maybe start, is 30 degrees. If that happens to give you the same thing on both sides, you could just pick another number. So we're just trying to find a angle that doesn't work. Okay, so let's say I plug 30 degrees in. On the left, it would be 2 times 30 over 2. And on the right, it would just be sine 30. Okay, so from your unit circle, what's the sine of 30? We cannot forget our unit circle. Yes, 1/2. Okay, now on the other side, I'm going to have sine of 60 divided by 2. What's the sine of 60? It is rad 3 over 2 divided by 2, which instead of dividing by 2, you can picture it as times 1/2. That's the same thing. So if I do rad 3 over 2 times 1/2, I get rad 3 over 4, which is not the same as 1/2. So x equals 30 degrees is a counter example. You have disproven it. Okay. Decimals are fine with this too, if you want, because we're disproving it. So that's fine. Okay. Any questions on that? Number 1. Cool. All right. Number 2. Most of the other problems on the test are just going to say find the exact value, which number 1 means no decimals if it's an exact value, and number 2, you're probably going to use an identity to figure it out and your unit circle values. Okay, so let's pick one of these. What do we like? 24. Okay, so I have secant of pi over 12. All right, so if you have a radian, what should you probably do first with it? Convert it to degrees, so pi over 12 times 180 over pi, I think gives me 15. Yeah, good. Okay, all right, so now I'm finding the secant of 15 degrees. We do not have identities for secant when they're weird angles like this, so what are we going to use instead? The reciprocal. So first we're going to find the cosine of 15 degrees. Out of all the identities you have on there, probably the easiest group to use is sum and difference. So I would start with that. If you can use the sum and difference, find two angles that add or subtract to get to your given angle, that's what we want to go with. So can you find two angles on your unit circle that add or subtract to 15? You could do 45 minus 30. So that's our U and our V. Okay, so on your identity sheet, which again, you'll have all these formulas, you just need to know how to use them. You're going to look for cosine U minus V. So that is cosine plus sine. Okay, filling in my U and my V, and then evaluate all four of those with your unit circle. What's the cosine of 45? Rad 2 over 2. What's the cosine of 30? And 3 over 2. Sine of 45. Rad 2 over 2. And sine of 30. 1/2. Okay? So we multiply those together. Just going to multiply numerators and denominators. My numerators, I'm going to have a rad 6, a rad 2. They're both going to be over 4, so you can just say all over 4, get that common denominator all at once if you want to. And then that's the answer for cosine 15. So at this point, you could check. You could type cosine 15 in your calculator in degree mode, type your answer in your calculator, and make sure the decimals match. Now we're not quite done because this was a secant. So if I have the cosine, what do I do with it to get the secant? Just gonna flip it. So back to the top now. I get 4 over rad 6 plus rad 2. How do you rationalize if there's a plus or a minus in the denominator? Multiply by the conjugate. So rad 6 minus rad 2. Rad 6 minus rad 2. So in the numerator, I'm distributing 4 rad 6 minus 4 rad 2. In my denominator, you're foiling, but they're conjugates, so you only have to do first and last. So first, rad 6 and rad 6 just give me 6. My last terms, positive rad 2 and negative rad 2 just give me negative 2. So that denominator is just going to become 4. And then everything there is divisible by 4. So final answer, rad 6 minus rad 2. Okay, which again, you can check that. You can take the reciprocal or just take this and flip it, really. Type in 4 over rad 6 plus rad 2 and make sure you get that same decimal if you want. Okay, so you've got a few different places there you can check as you go. Any questions on that? Sum and difference identity. Okay. Next one, this again is going to be sum and difference. Pick a problem. What do we like? 56. Okay. So we're going to do tangent u minus v. Before I do anything with the actual problem, I'm going to take my given information at the top and see what I can do with it. Okay, so tangent u is 3/4, and U is in quadrant 3. If I'm being told what quadrant something is in, what should I probably do? Draw a picture. Okay, so quadrant 3, let's get that picture here. And this is angle U. Make sure your right angle is on the x-axis, your angle's near the origin when you draw those reference angles. Okay, tangent is 3/4, so we know that's opposite and adjacent. Opposite 3, adjacent 4. What's my missing side of my triangle? 5 is anything negative. The 3 and the 4 are both negative. Okay, then I also have sine of V is 5/13, and V is in quadrant 2. So I'm going to do the same thing. I'm going to draw a triangle in quadrant 2, and this is angle V. Sine is opposite over hypotenuse. Do you know what the missing side here is? This is another triple. 12, and it's negative because we're in quadrant 2. Okay, so all of that, it doesn't matter what you would have picked, 51 through 56, you would have to do these two triangles, start out exactly the same way. Once you have the pictures, now you go to the identity you're trying to find, which in this case is that tangent U minus V that you guys picked. So you can find that on your sheet. It's tangent U minus tangent V all over 1 plus tangent U tangent V. So all I need is tangent U and tangent V. And actually, tangent U was a given. That was 3/4. Tangent V, I'm going to need the triangle for. What is the tangent of V? Opposite over adjacent? 5/12, 5 over -12, so -5/12. And then you guys are going to have your graphing calculator, so you can just type that whole thing in the calculator. Just be careful with your fractions. Maybe alpha y equals it a couple times. I'll type it in too. And double check you get the same thing as me. Again, make sure no decimals, you get a fraction answer at the end here. So my numerator is 3/4 plus 5/12. My numerator is 7/6. Just leave that there for a second. My denominator, 1 plus 3/4 times -5/12, which is 11/16. And then you can just divide the two. 7/6 divided by 11/16, 56 over 33. Your final answer there. Thank you. Julia. May office. Move that now. So, well, let's just do these last couple problems, then you can head down with them. Any questions on this one? Okay, number 4. Another exact value. This is going to be a double angle problem. Pick a number. What do we like? 12. Okay, and I'll write it a little bigger for you. So we've got cotangent theta is -7. And we're also told that theta is between 3 pi over 2 and 2 pi. Now at the top it says find sine, cosine, and tangent of 2 theta. I won't ask for all 3 of them on the test. I'm just going to ask for one of the 3. So do you guys have a preference which one you want to do? Sine, cosine, or tangent? Sine, sure. Okay. All right. So if theta is between 3 pi over 2 and 2 pi, what do I know? It's in the 4th quadrant. And what do I know if I know a quadrant? I have a reference triangle I can use. Okay, so draw my reference triangle. There's my theta. I know cotangent. You can think of it as -7 over 1 if you want to see that fraction. Okay, so tangent is opposite over adjacent, which means what we have is adjacent over opposite. And one of those is negative. Which one in this picture makes sense to be negative? The 1 is negative because we're in quadrant 4. So it's 7 divided by -1. That's where that -7 is coming from. Okay, now this is not a Pythagorean triple, so you need the Pythagorean theorem to get the hypotenuse. So probably do mental math on this one, right? What's 7 squared and 1 squared added together? It's 50, square root of 50, which that breaks down. What does it break down to? 5 square root 2. It breaks down to 25 and 2. Square root of 25 gives me 5. There we go. All right. The triangle will give me what I need to fill in my identity. Remember, sine 2 theta does not mean find the sine and double it. It means use the identity on your sheet. Okay, so under double angle identities, sine 2 theta, or 2x on your paper, is 2 sine cosine. So you need those two pieces. And remember, when we're finding a fraction from the triangle, that is the sine. It is the cosine. So the sine and cosine are going to disappear when you start plugging things in. Okay, we're not just plugging it in for theta. We actually don't know what theta is. All we know is what the sine of theta and cosine of theta are. So those are going to go away. All right, so I'm going to have 2. My sine in the triangle opposite over hypotenuse. So -1 over 5 rad 2. And my cosine is adjacent over hypotenuse. And remember that 2 out front is a 2 over 1. Okay? So we're multiplying all the numerators together, all the denominators together, and you can use your calculator as you see fit here. The numerators are going to give me -14. The denominators, 5 times 5 gives me 25. Rad 2 times rad 2 gives me 2. So I have 25 times 2, which are going to give me 50, and then you can reduce that, -7/25 is the final answer. Okay. Questions on number 4, double angle. Okay. Another exact value, pick a problem. 52. Okay, cosine 112.5. So if it wasn't already a degree, we'd want to make it a degree. Okay, that's done. Also, if it were a negative angle, like let's pretend my original problem was -112.5. What would you do? I wouldn't do that only because we're going to have to double it in a minute, and you're going to get something outside of your unit circle. What other group of identities could we use to get rid of a negative angle? Remember? Even odd identities I would use. If I have a negative angle, I would look at the even odd identities. Now, it's a cosine. So again, let's pretend it's cosine of -112.5. What do I do with the negative if it's a cosine? Do I get rid of it or bring it out front? Those are the two options. You can get rid of it. If you look on the paper under even odd, cosine and secant are the only two where the negative disappears. The other 4 are odd functions, which you could just bring it out front then. But either way, then you're getting rid of your negative, and you don't have to worry about making the angle bigger, and then when we double it, it's going to get even worse. Okay, so make sure you've got a degree, make sure it's positive, and that's already done for us. Now the 0.5 is a giveaway. If it's half of something, you are using your half angle identities. So that's where we want to look next. The first thing you want to do is write it as something divided by 2. So what angle, on your unit circle if you're doing this right, divided by 2 gives you 112.5. 225. That 225 is the theta that you use in the formula. Okay, so your half angle identity for cosine looks as follows. Plus and minus, square root, 1 plus cosine of our angle, 225, over 2. Simplifying, let's start with the plus or minus. The plus or minus is determined based on the original function. Okay, so 112.5 is in what quadrant? It's in quadrant 2. If you are a cosine in quadrant 2, what are you? You are negative. Okay, so you can decide that at the beginning or you can decide that at the very end, either one. All right, what is the cosine of 225 off of your unit circle? It is negative, rad 2 over 2. All right, that's our answer. We just have to make it pretty. First thing we're going to do is multiply by that little denominator we don't want. So we're going to multiply by 2 over 2. That's going to give me, in the numerator, when I distribute it through, 2 will be plus a negative, so it'll be minus rad 2. And on the bottom, 2 times 2 gives me 4. And then remember, when you have a square root over a fraction, you can think of it as the square root of the numerator over the square root of the denominator. So my numerator, I'm not going to be able to do anything with that. It's just 2 minus rad 2. It's going to stay there. But the denominator is a square root of 4, which we can simplify to 2. Okay, and again, this is one you can check with the calculator. Type the problem in, type the answer in, make sure the decimals match. Okay? Good there? All right. Number 6. Pick a problem. Finding an exact value again. What do we like? 27. All right. So I've got sine 5 pi over 24, cosine pi over 24. Okay, so one thing that can be tempting here is wanting to evaluate each of these individually, especially if it was like something over 8 or something over 12. We could maybe use other identities to simplify each piece, but each piece in itself is a little bit messy. So for this, we're going to use the product to sum identities. We're going to take something that's multiplied and change it into addition or subtraction, and that will hopefully give us angles when we combine the pi over 4 and the 5 pi over 4 together that are on our unit circle and allow us to evaluate it. Okay, so product to sum is what we're using. These are the ones with the 1/2. I got to remember all my pluses and minuses on these ones. All right, so what do I have? No, I have a sine, cosine. All right, so sine for both of them, plus in between. All right, so first thing I'm going to do is add my angles together. 5 pi over 4 plus, or 24, plus pi over 24. And then in the second group, it's x minus y, so we're going to subtract our angles. Okay, and you can maybe do that part in your head even if you want to. What's 5 pi over 24 plus pi over 24? 6 over 24, which reduces to pi over 4. Okay. Then I have 5 pi over 24 minus pi over 24. What does that give me? Pi over 6. It'll give me 4 pi over 24, and then that reduces. And now you know you're doing this right because we're getting unit circle values. What is the sine of pi over 4? We're at 2 over 2. What is the sine of pi over 6? Ooh. I'm writing, but it's not showing up. I think, oh, yep. That's fun. It's great. It's awesome. Let me see if I can hop to another connection real quick. That was my BYOD that went down. Everything's down. Awesome. Was it down earlier today too? Oh. Oh yeah, because you couldn't get your Blackboard. That's right. All right. Give me a second. Let me see if I can reconnect it. Oh, wait. Yay. We're back. Okay. Rad 2 over 2 and rad 3 over 2. Let's distribute. I'm going to get a rad 2 over 4 plus a rad 3 over 4. So final answer will be rad 2 plus rad 3 over 4. Make sure if you have fractions that are being added together, if you don't have a common denominator, you get that common denominator, you combine them. Okay? Questions on 6? Yes.
Wait, isn't the sine of 5 over 6?
Yes, it is. Man, I was trusting there. Dang. Trust is broken. Rad 2 over 1 plus 4? Sound better? Who do we blame for that? Luke. All right. I didn't catch it, though. That's my fault. All right. Good? Yeah? Any other questions on that one? Okay. Number 7 is, again, find an exact value problem. Should be the easiest one on the test. Looks the most complicated, should be the easiest. For real. Pick a number.
625.
What? 625.
45.
45. Tangent 129 minus tangent 84 over 1 plus tangent 129 tangent 84. Okay, so again, it might be tempting, depending on what angles you're given here, to want to like evaluate each piece. Don't do that. So what you have here is one of your identities. Find it on your sheet. Tangent minus tangent over 1 plus tangent times tangent. What identity is this? It's sum and difference for tangent. Is it addition or subtraction? It's the tangent sum and difference. Tangent u minus v. Everybody see that? So they filled in the hard part of the formula. You're going to use the easy part when you do this. And it could be a double angle or it could be a half angle, but you're just going to find it on your sheet and work backwards. What was the u? 129. And what was the v? And what is 129 minus 84? It is 45. And what is the tangent of 45? 1. Could you check that answer? Absolutely. Type that giant thing in. Make sure you get 1. Perfect timing, because we're done. All right, so that is what Tuesday's part of your test is going to look like. 7 problems just like this. You guys know that we've got lots of extra practice problems on Polaris, just like these 2, if you want to use them over the next few days, all right? You don't have any more homework for the next few days. It's just study as you see fit. Yes? This part is going to be on Tuesday, and the second part is on Wednesday. Nothing tomorrow. Let's talk about tomorrow.